Grade 8 Math, number 10.1c. We're talking about transformations and similarities in this chapter. We're doing properties of dilations. Now we're going to find a scale factor. So we know from the last couple of videos that a dilation can make an enlargement, a larger figure, or a reduction, a smaller figure, and the scale factor tells us how much the figure was enlarged or reduced. The scale factor is a ratio, it's a fraction, of the length of the image compared to the corresponding length of the original figure. So it's like this. You got the image in ratio to the original, see? The image to the original as a ratio. It's the image over the original. It's the image over that pre-image. That's the same thing as the original. So you would have the labeled ones with the tick marks of A prime, B prime, C prime, or XYZ, whatever it is, with the little tick marks, the little prime marks, over the one that doesn't have it. So that's how you know that's the original and that's the copy, because the one with the tick marks is the copy, okay? That's the numerator. The original will be the denominator, see? That's how we can compare them. So, a dilation, remember, is a transformation that changes the size but not the shape. So, if we need to find the scale factor for a dilation, we can use the x and y coordinates to find the lengths of each triangle. Because the scale factor is the same for all corresponding sides, we can record just two pairs of side lengths and one pair can check the other. So we don't need to compare all three of the lines of the triangle. We could just do two lines. We could do the AC and the CB. That's it. We don't need to do the hypotenuse, okay? That's the long side. We don't need to do that. We can just use these two. If these two are the same of a triangle, well, then the triangles are similar, okay? So we record the image first. The image is the one that's got the tick marks. So see how these labels are clean, ABC? This is the one that's got the prime marks, the tick marks. So that's the image. That's the copy. All right, so we're going to record the XY coordinates for the pink one first. Line AC is 4 centimeters long, so we're doing the lengths first. It's 4 centimeters long, and C prime, B prime, that's this pink line right here, that's 10 centimeters long. And then we do the pre-image, the original. Line AC here is 2 centimeters, and CB here is 5 centimeters. We find the ratio of the corresponding sides of the figures. We put AC over A prime, C prime over the AC, and we get 4 over 2, which is 2. And we put C prime, B prime over the CB, like this, and we get 10 over 5. That equals 2. And the scale factor for the dilation is 2. They're both 2. So we know that the hypotenuse would end up being 2 also. It's an enlargement because the image is bigger than the pre-image. And the scale factor is greater than 1. See, if the scale is 1 to 1 or 1 to 1 as a ratio, then they're both the same scale. They're both the same size. There was no dilation. There was no change. They're both the same and didn't move at all in enlarging or reducing. They stayed equal to each other. So it would look like this. So if you have the scale factor, the original size is a 1. If the scale factor is between 0 and 1, well, then the image is a reduction. It's smaller than the original size of 1. If it's bigger than 1, then it's an enlargement. The 2 would mean it's 2 times bigger. The 3 would mean it's 3 times bigger, etc. 4 is 4 times bigger. Now, it stops at 0 because if you have an image and you reduce it down to the size of 0, it's gone. So it can only go to 0, see? So in between 0 and 1, it's a reduction. It's smaller than the original size, all right? Now, what's cool about triangles is when we measure the sides, they were different, right? They had different side lengths. One was double the other one. The image, the copy, is double the size of the original, but the angles are the same. When we look at the measure of angle C right here in the corner, it's 90 degrees. It's perpendicular just like C prime. See? C prime is 90. The measure of angle A is 58 and A prime is 58. Measure of angle B is 32 and B prime is 32. Well, the side lengths are different, But similar triangles have the same angle measures. They just have different side lengths, see? So your angle measures are going to be exactly the same. These are similar triangles with the same angle measures, but the lengths are different, okay? So that's how we find a scale factor. Remember that it can only go to 0 because then it disappears. It gets so tiny it's microscopic and we can't see it anymore, all right? Whew, a lot of information to remember, I know. We're going to get through this. I'll see you next video, and keep trying. I'm proud that you're making it through this, and we'll be okay, all right? Bye.